So this tutorial is called logic gates, but actually it's on Boolean operations, which is basically logic gates but used in the code. So we're going to be looking at and or gates. So to help us understand Boolean operations, we're going to look at logic gates and truth tables first. So first we'll look at and gates, which if you're looking at an actual physical and gate, it looks like this. So you've got input 1 here, input 2 here, and an output. So we can make a truth table of this, and it would look something like this. So we got in 1, in 2, and an output. So with an AND gate, so this is an AND gate, if in input 1 you input a 0, so 0 volts, and in input 2 you input 0, like 0 volts, you'd get 0 volts out. If you input 0 into input 1 and 5 volts, or a 1, into input 2, you'd get a 0 out. If you input 5 volts or a 1 into input 1 and a 0 into input 2, you'd get 0 out. The only way to get a 1 out is to input 1 and 1, which is why it's called an AND gate. So the way we write an AND gate in Boolean is double ampersand. So that's like that. So it's a double AND. So now we're going to look at OR gates. So OR gates look like this. So that's an OR gate. So you've got in 1 here, in 2 here, and out here. So if we draw that in a truth table, we have in 1, in 2, out. So if we put 0 into both inputs, we get a 0 out. If we put 1 into one input and 0 into the other, we get a 1 out. If we put 0 into the other one and 1 into the other one, we also get a 1 out. And if we put 1 into both, we get a 1 out. So they're called OR gates because if you have 1 or 0, you get a 1. If you have 0 or 1, you get a 1. If you have a 1 and a 1, you get a 1 as well. So the only way to get a 0 is to have 2 zeros. The way we draw an OR logic gate in Boolean is to have 2 uprights. I don't know what they're called, but if you press Shift and the backslash key on a keyboard, it's that character. Just on a side note, you won't need this for Boolean, but if you're working with logic gates, if you see a NOR gate with an N in front of it, it means that these outputs are inverted. So if this was a NOR gate, the outputs would be 1, 0, 0, 0. And that is the same with an AND gate. So if it was a NAND gate, the outputs would be 1, 1, 1, 0. So it's just the inverse of what it should be. So I've wired all my buttons and LEDs up to the corresponding digital pins, as well as to the 5-volt line and the ground line. So now when I press the left button, the left LED will turn on. When I press the right button, the right LED will turn on. Now when I press both at the same time, the blue LED will turn on. So now we're going to move on to code, and so I'm just going to fly through the setup quickly and talk you guys through it. We've already done it a few times, so I'm just going to talk through it quick. So we've got the left button and the right button, so I'm going to go int button L for int button left equals pin 6, int button R for button right, and we're going to set that up on pin 7, and then we've got our 3 LEDs, so we've got int red left equals 1, because we wired it to pin 1, int red right, pin 2, and int blue equals 3. And then in the pin modes, we write pin, don't forget the capital M of mode, and we write button L is an output. Oh, no, sorry. Button L is an input. My bad. Pin mode. Button R is an input. Pin mode. Red left is an output. Don't forget this is all capitals, and don't forget this semicolons as well at the end of the lines. Red R is an output. Pin mode. Blue is an output. And don't forget that's because we're digital writing into the LEDs, so they're outputs, whereas we're digital reading from the buttons, which means they're inputs. So now we've done all this setup, we're going to move into the void loop, and we're going to use if statements to work out which buttons have been pressed and create outputs based on that. So what we want to happen is we're going to turn the right LED on when we press the right button. We're going to turn the left LED on when we press the left button. But when we press both at the same time, we want the blue LED to turn on. So we're going to use if statements and logic gates to make this happen. So we're going to start by saying if, and we're going to take a digital read of the left button, so button L, is equal to high. So we're saying if the digital read of the left button is high, and then we're going to say and, which means that's the symbol for an AND gate in Arduino code. So because we want to check both the left button and the right button at the same time. That will become clearer in a second. If digital read button R is also equal to high. And now we're going to close our if statement. So what we're doing is we're checking both buttons at the same time. And if the left button and the right button are high at the same time, then remember from what I said at the start, we want to turn the blue LED on. So we say digital right blue high, and that's going to turn the blue LED on. And then we're going to want to use an else statement to turn the LED off if that statement isn't true. So we're going to say digital right blue low. So that's going to turn it off when this isn't true. So now what we've done there is when we press both buttons at the same time, it's going to turn the blue LED on. Now we want to say if one button's pressed but not the other, then we want to turn on the corresponding LED. So let's start by wiring up the left side to turn on when we press the left button. So we'd say if digital read button L is equal, and we'd write high again here because we want this to be triggered when the left button's pressed. Now, some of you might be thinking, oh, we could just end the if statement there, surely, because that would be true when we press the left button. But because we're not checking the value of the right button, it would mean that this statement and this statement could both be true at the same time, which isn't what we want, because then the blue and the red left LED would be on at the same time, which we don't want. We want either the red left, the blue, or the red right to turn on. So what we're going to do is we're going to add another AND statement and say if the digital read of button R is equal to low, which means basically, so if this button has been pressed, but this one hasn't been pressed, then we're going to turn the right LED on. Because remember up here we want the blue one and only the blue one to turn on if we press both buttons. If we didn't have this second part of this statement, then the blue one would turn on, we'd exit that code, and then this statement would also be true and we'd turn on the left LED. So by adding this statement here, we make sure that this statement is false when this one is true. So now we're going to add our digital right, so we're going to say digital right, and we're going to say the red LED on the left is going to go high, close the bracket, semicolon, and then we have to add an else statement for that. Else digital right red left is low. Okay, and now we have to write a final if statement for the right hand side. So we start by saying if the digital read of button left is equal to low, and the digital read of the button right is equal to high. So in other words, if button left isn't being pressed and button right is being pressed, then we're going to turn the right LED on. So we're going to say digital right, red right, high, and then we're going to add that last else statement. We're just going to check that, and it's all good. So we're going to upload that to the board and see how that translates to the Arduino.
So now instead of using an AND gate, we're using an OR gate. So if you press this button or this button, then the blue light's going to turn on.
So we've started afresh in the void loop. Up the top I still have the same setup code as I had before. So what we're trying to do is turn the blue LED on if we press button left or button right. So let's start writing that up using an if statement. So we say if digital read of button right is equal to high, i.e. if we press the button on the right. And then we say use an OR statement in Boolean, which is these two uprights like this. So this is saying if the digital read of button right is high, or if the digital read of button left is high. Then we can close the if statement. Open our squiggly brackets and digital right blue LED high, which is on. Then we can just use our else statement to turn that blue LED back off again when we're not pressing either of the buttons. And there we go, we can upload that and see how that works on the board.
So if we press this one or this one, it's going to turn on. And if we press both, it's still going to turn on.